Despite many companies still investing huge amounts to establish data science capabilities, the hard truth is the vast majority of these projects fail to impact upon daily business operations. As such, today on Lokad TV, we're going to look past classical statistical modelling and discuss why data science departments must do more than just collect data, manipulate it, and provide results. So Johannes, most of us are still kind of getting to grips with classical statistical modelling. So what's the key idea today?
I mean, there are several ideas. First, I'm using the term, statistical modeling that I suggested for this episode because literally when the data science practice, as they are envisioned in most companies, by most people in those companies, is just glorified statistical modeling. So, by the way, for the general audience, in case you're wondering, when it comes to basically do anything in terms of, extracting patterns or, replicating some aspect of human intelligence, all we have right now at present time is statistics. Those statistical methods can have like very fancy names like deep learning. Some people will refer to them as AI or whatever, but literally what we have is statistical models. In the past, a few decades ago, there has been attempts of doing AI with approaches that were non-statistical. That was basically the symbolic approach, which yielded about 0 practical results. Not exactly true, but almost. And thus, basically, this branch died out, leaving, I would say, the other branch, which was the statistical approach, which is literally the only one that still exists to any meaningful degree at present time. So all we have, to basically do anything fancy with the data is statistical methods. And the interesting thing is that what are those teams doing, in most companies that are actually doing data science? Well, they are playing with models, statistical models. And I'm opposing that to what, if you look at what, let's say, people who are really serious about it, like let's say the Google, the Microsoft, the Amazon, what the people that are really serious about it, what they are doing. They are not doing statistical modeling. They are really rethinking at the core the next stage of what the very nature of the next statistical method will be. It's literally about inventing deep learning versus playing with deep learning. It's about invented, the next stage of gradient boosted trees as opposed to take gradient boosted trees, one statistical model and just apply it to a data set another. So you see, we have that, and the problem is that literally we have people that are, having those models, and what they're doing is literally combining models that they haven't produced in, I would say, near infinite ways.
Okay, so the common understanding is that these teams are kind of going in, they're collecting data, they're cleaning it, they're sort of applying their statistical models, and they're kind of providing results. What is it that kind of the Googles and the Amazons are doing that's so much better than that?
I think to answer this question, we have to go back a bit in time and rethink a bit about, let's go back, 19th century electromagnetism. This is this brand new thing. And if you read a bit the history, how people were approaching that, you would say, oh, electromagnetism is so incredibly, interesting. Imagine you're I would say, an industrial company of the time. A pre-industrial company. You have like a manufacturer that is semi-manual, etc. And then you have this electromagnetism thing that is, becoming of interest. And you say, and literally, you say, oh, I think it's really worth having like a small team, doing some fancy things with that. And maybe, for a quality insurance, we will have a few things where we can test conductivity, and that's very promising. And we will do a few things that are of interest, because yes, testing conductivity is a great way to do quality insurance on a few things that we produce. And then if you rethink about that, a century later, you would think this is nonsense. I mean, with electricity, you can have engines, you can have electrical lightnings, you can have heating, you can have cold, you can even melt metal. I mean, literally, it will replace all the needs for having like open flame in your manufacture. So literally, once you have, you know, not electromagnetism, but literally electricity at scale, you can literally reinvent pretty much everything in the way you're doing it. So the thing is, the way data science is envisioned, it's literally something that is a fancy gadget, you know, and people are, you know, abiding by the frame of the way the problem presents itself. So and so, you know, the way it's done in academia is to present the problem like you have a data set well defined, you have a series of models, you have metrics for accuracy metrics of some kind because you want to do a prediction of some kind, and we are going to, you know, explore the various models and look for the model that perform best. And that's, by the way, that's literally this very idea is literally embodied in this in the Kaggle communities that we discussed previously. So and literally, so people say, well, everything has been framed about there is a data set that is a given, there is a problem with a metric that is a given, and then there is an endless collection of models, and most of them can even be, you know, composed in many ways, and you can potentially re-engineer the features that you have to basically so that the data set is nicer with respect to the model that you have. And that's data science.
So what is so wrong about that kind of Kaggle mindset? Is it just kind of overly simplistic and it's just telling you that you're just going to have one result that's going to be accurate, or why is it so wrong?
Because again, if you look at the history, and again, it's something that you only see once, you know, once in the past, it becomes, I would say, absolutely obvious. But at present time, it's always when you're at the fringe, it's difficult to see it. Once you're past, I would say, once it has become the norm, it's like so obvious. So now, if I go back to data science, literally what I see is companies invariably take, I would say, pet projects, I would say, pet application, you know, the sort of fancy numerical gadget where you've plugged a bit of AI. I would say probably the thing that is the most absurdly, you know, useless are the chatbots. But and I know that there is a lot of people who have raised a lot of money to develop, you know, great companies who can, you know, dynamically learn how to discuss on Twitter and become Nazis in 48 hours just because people fed the right inputs, and this sort of nonsense. But back to that, I mean, again, the problem is that when you want to think about what a new technology entails, it's not a one-way process. I mean, people think that, oh, we have this universities discover things, they are teaching them to students, and students who are now graduates, you know, they have engineering degrees, they have computer science degrees, etc. They go into companies and they roll out the innovation. But it's absolutely not the way the real world works. The real world is Amazon pretty much, you know, invented what was about to become, you know, e-commerce. And a few others, you know, eBay and the few pioneers, they really, you know, they pretty much through their innovation defined that. So it wasn't, you know, Jeff Bezos didn't went, you know, somewhere in the early 90s say, you know what, I'm just going to hire webmasters and build a website. I mean, they literally had to go through of thinking what what would be the future of commerce at a distance. And that was something profoundly different from what has been done so far. So data science, you see, the problem is that you think that it's about having a frame where you can have smart engineers that roll out the solution, when actually the process is much more, you know, I would say an ongoing discussion where the business literally gain insight in some new technical capabilities and then project themselves in what should be the business of the future, and then establish, you know, the requirement of what is missing tech-wise to actually implement that. And usually you realize that most of the innovation comes from the requirement. You establish the requirement, and then once you have a clear view of what you need, usually the solution is not that hard to come up with once you know which question to ask.
Okay, and why would you say that the majority of data science departments are still kind of stuck in those kind of academic ways? I mean, why not more of them more like Amazons of the world?
I mean, first, because if you're a company of a certain size and you see those buzzwords, the lazy way to be at it. I mean, I believe to a large extent, it's always, the mortal sins. Either it's greed or gluttony or laziness, etc. And here, laziness. So the problem is that it's way easier for large companies to just add a line in their budget where they are going to spend a few millions a year on the buzzwordish approach of the day. If it's a data science team, yes, let's go with that. Blockchain is a thing. Yeah, let's have a blockchain team as well. So they will routinely phase in something that is the buzzword of the day, routinely phase out something that went out of hype, and it's just business as usual. And my message is that if you want to do anything that is that has any substance, is if you decide that you want to do anything with I would say those fancy numerical methods, you really need to ask yourself what would be, what does it profoundly change in your company? What should it change? And if basically all it change is like a cosmetic thing, such as, we are going to auto-compute the ABC classes in a way that is going to be, better. I really challenge. It's not. I mean, it's literally completely cosmetic. It will not change anything to your company.
But surely changing the entire kind of business model of a company to adapt to some kind of new technology is inherently risky. And
yes.
So would you not say that that's the reason there's so much kind of resistance to that sort of change, is because fundamentally, if people don't understand it, there's a lot of risks associated with it because it's a new technology. So it's much safer to just kind of leave it as it is and just kind of invest maybe in a little bit of research and development.
The problem is, what is the ambient risk of going out of business just because you've become obsolete? And for most companies, this risk is actually quite real. So the problem is, I've been discussing with many retailers for over decades, and literally 10 years ago, I had a real discussion where I was telling them, this company, Amazon, is coming, and literally they will eat your lunch. You need to do something. And people were telling me, but look, it's so small. Yes, it's growing, but it's not even 1% market share. We don't care. And nowadays, if you look at Amazon and Alibaba, they're absolutely gigantic and they're still growing, which is insane because considering the amount of diseconomies of scale that they're suffering, when you grow past a certain size, you don't get economies of scale anymore. You get diseconomies of scale. And Amazon is way past their stage of diseconomies of scale. So they have like massive handicaps for anything that they do because they have such, I would say, diseconomies of scale. So if they want to even still have 1% of growth, they have to overcome absolutely massive diseconomies of scale. And so that means that they are not doing something that is marginally better than most other companies. They are just light years ahead. So first, indeed, as an executive, not doing anything or, never challenging the status quo is literally the safest, card you can play. No question about that. The problem is that if you play this card, continuously for a couple of decades, well, the company just go bust. So my message would be for the CEO, can you, tolerate that this mindset is prevalent in your company? Don't you see any problem looming ahead? And if you don't, well, I would say, nobody will shed tears on the fact that you've gone the way of the dodo.
But it's like kind of these advanced statistical techniques are very much kind of the flavor of the month at the minute, and people are always talking about those buzzwords like AI and deep learning and things like that. But how much confidence can you have that in 10 years' time this will still be a topic of importance to these companies?
That's, again, good question. I mean, first, the achievements, what companies like Google or Amazon or Microsoft achieve with those sort of technologies is just stunning. I mean, literally, we went from, for example, programs that have really hard time to, outperform a chess grandmaster to something that is now beating, the champion of chess. And if you look at the latest work of Google, you can go from 0 to impossibly, inhumanly good in 4 hours for chess. So they can basically set up a program that will learn to play chess, and in 4 hours reach a point that is literally inhuman, where it will beat every single human alive. And to a point where it's not even, the parties themselves, it's very interesting. The parties, how they are played by the computer, are just incomprehensible, because it doesn't make even remotely sense of what is going on. So that's, okay, so you have like stunning achievement, obviously for very narrow problem, well defined. But if you look at autonomous vehicle, it's absolutely stunning. It does work. Question is, can it be industrialized? We still have edge cases extra, but the amount of progress is literally stunning. So the fact that you can take this leap of faith of saying, well, those sort of technologies, they are there, they're proven to work, at least on a long series of cases. The odds that those things, I think it's a very reasonable, belief that you can have to say that, well, odds are pretty high that those things will completely, let us to reinvent the way supply chain are done. And by the way, in the case of supply chain, it's not even going to be very new, because if you look at, Lokad, we advocate this vision of quantitative supply chain, but if you look at what is being done in banks, in finance nowadays, it's all about quantitative trading. And they have quants, and it's literally, it's not even the future, it's already there, and it has been there for 2 decades or more. So now the idea, and I believe that this approach is coming with 2-3 decades late to basically supply chain, but it has already been in place for decades in finance.
Okay. If somebody's kind of watching this and they're wondering what they need to do to kind of instill that kind of culture in their kind of data science teams, what are kind of the steps they should take? How should they kind of push their teams to take more risk and sort of be a bit more kind of groundbreaking and move against kind of the easy status quo kind of options?
I think you can have a litmus test, a simple one, which is, if the company were to fire all the data scientists that they have, overnight, just fired, would the company be in desperate trouble, in mortal trouble? Would the company go bankrupt in 1 year? And if the answer is no, then probably those people are inconsequential. And so whatever you're doing with those people doesn't matter. You would say, oh, but it's so much risk, it's so brutal. And again, reconsider the situation of Amazon the early 90s with the web, this nascent thingy. I mean, people would say, oh, but we have such a dependency on those web engineers. Is it insane to imagine you could sell at a distance and be perfectly fine without having such an incredible dependency with those web developers? This is insane. Why are you taking such a risk to be dependent on this, on these technologies that frankly look super crappy? You have this modem that is super slow. It makes beep, 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 beep. It takes like 3 minutes to establish the connection. This is literally pile of crap on top of pile of crap. And then you can have images that have a resolution where frankly is so bad. I mean, first you wait 1 minute to have the image of your picture of the product, and then it's super crappy. This paper catalog is so much better. I mean, literally real-time, access to all the products, high resolution picture. This thing as a web is just, a big crap of nonsense. And why would we take any risk on having like a hard dependency company-wide on those web developers? Well, the answer is because if you don't, 10 years down the road, 20 years down the road, you don't exist anymore. So obviously, I'm playing something. With inside, things are way more obvious. So it's hard for me to convey that. But the thing is, I think many companies have realized that. And so that's why they have hired those data scientists. But they don't realize that, the question is, do you have a strategy where at the core, executives really play those technical capability to their best, and really that requires some strategic thinking, and again that requires what I call typically mechanical sympathy. Just like the Formula One driver, this person is not an engineer capable of building an engine for Formula One. But if you've ever seen interviews of Formula One drivers, they are exceedingly knowledgeable about the mechanics, what goes on in their car, because so that they know exactly how to push the machine to the limit. And again, my message for a company would be, do you have mechanical sympathy so that you can, have an intelligent, educated discussion with those engineers that are, building the engine for your company?
So would you say that's one of the real kind of big blockers when it comes to kind of data science in companies, is the fact that executives probably currently don't have that kind of level of mechanical sympathy that they need?
I mean, frankly, if you could, reinvent companies by hiring 24 years old, people and let them do the magic, it would be fantastic. But literally, if you look at, again, the history of companies, I think the number of times things happen that way, you hire one brilliant engineer that happened to completely revolutionize 24 years old, a 50 years old company from the inside. No, I've never seen. I mean, literally, maybe in the audience, some people will come up with some weird cases that I didn't know about. But literally, this is not the dominant pattern. The dominant pattern is you have either super young people who are, or basically people of relatively any age. I mean, it's when entrepreneurs are usually either super young or 45 plus, just because, with regard of the children, you have this dead period of, if you're 30, 35, it's typically the wrong time because you're just establishing your family. So if you look at patterns for entrepreneurs, you're either super young, fresh out of university, or like 45 with basically some capital, experience, and maybe some degree of wisdom, etc. So you have those two types. But and typically it takes a new company to get that. So again, the thing is that my advice would be, if you think that hiring people fresh from college is going to cut it, to revolutionize your company, I think let's be serious. This is wishful thinking. This is not serious, and I would say intellectually it's laziness at best.
Okay, we'll have to wrap it up there, but thanks for your time. So that's everything for this week. Thanks very much for tuning in, and we'll see you again in the next episode. Thanks for watching.